Good afternoon, everyone. Today we're going to discuss about molarity, and mole fractions. I'm going to write the topics or the subtopics. It's going to be molarity, and mole fractions. So first, I would like to start by giving you a definition. What's molarity? Molarity, in most literatures you see uppercase M's. That's very important. Molarity is defined as the number of moles of a solute. Per volume of solution. And the volume of solution has to be expressed in terms of liter. So we can abbreviate this by saying N over V. That's how molarity is defined. So from now on we're going to use M, the big M, for molarity, N over V. And we can able to deduce from this definition, we may have to calculate the number of moles if molarity and volume would be given N equals to M times V, or sometimes the number of moles in the molarity would be given and you would be asked to calculate the volume of solution. So volume of solution can be calculated as N over M, which is the number of moles of a solute divided by the molarity. The next one is molality. They look like the same, but there is a little bit difference with molarity and molality. By the way, molality refers as small m, which is, again, it's the number of moles of a solute divided by kilogram of a solvent. You have to be very careful here. That's a big difference between molality and molarity. Here we're dealing with kilogram of a solvent. In terms of molarity, we're calculating volume of a solution, which is in liter. Then we have mole fraction. What's a mole fraction? It's mole of the component, or the interested component, divided by the total number of moles. So we have molarity here, molality here, and we have mole fraction. What I'm going to do is I'm going to give you examples related with these three terms: molarity, molality, and mole fraction. So now we're going to start to discuss some example related with molality, and mole fraction. So I'm going to give you an example of mole fractions and molality first. Let's say that we have Let's say that we have 4.95% of sodium hypochlorite solution. Now, the question that's going to be for us would be based on this number of 4.95% of sodium hypochlorite. We would like to calculate the molality and the mole fraction. Okay, how do we do this? In order to do that, the first thing that we need to do is 4.95% of sodium hypochlorite has 4.95 grams of sodium hypochlorite and 95.5, around 95.5, or now if you subtract 4.95 from 100%, it might give you 95.05 grams of water. So you always see that the solute part is always less than the solvent part. So we have 4.95 grams of sodium hypochlorite and 95.05 grams of water. So when we want to do the mole fraction of the solution, the mole fraction of sodium hypochlorite would be moles of sodium hypochlorite hypochlorite divided by moles of water plus moles of sodium hypochlorite. That's the total number of moles. Okay, so how do we calculate the moles of sodium hypochlorite? The moles of sodium hypochlorite can be calculated as the mass of sodium hypochlorite, which is 4.95 grams, divided by the molar mass of sodium hypochlorite. The molar mass of sodium hypochlorite would be 74.5 grams. Now, for those of you, how do we get to 74.5 grams? We take the atomic weight of sodium, which is 23 grams. The atomic weight of oxygen is 16 grams. And the atomic weight of chlorine is going to be 35.5 grams. And we're going to add all this here, and we get 74.5 grams. Now, we divide 4.95 grams by 74.5. What do we get? If we divide 4.95 by 74.5, we would get about 0.066 mole. The same way, we're going to calculate the mole of water. The mole of water is going to be the mass of water, which is 95.05 grams, divided by the molar mass of water, which is 18 grams. 18 grams of water. So that will be around 5.28 mole. 5.28 mole. Now from here we can able to calculate the mole fraction of sodium hypochlorite. So the mole of sodium hypochlorite is going to be the mole of the mole fraction. It's not mole of sodium hypochlorite. Let me take off this. The mole fraction of sodium hypochlorite. Mole fraction of sodium hypochlorite is going to be moles of sodium hypochlorite. In our case, a mole of sodium hypochlorite would be 0.07 mole. Okay, divided by the mole of water. The mole of water is 5.28 mole plus the mole of sodium hypochlorite, which is going to be 0.066 mole, but you can round it up, 0.066 mole. So I'm not going to say 0.07, I would say 0.066 mole. So when we add 0.066 mole divided by 5.28 plus 0.066 mole, if you add these two here, you would get 5.35 mole. So mole and mole will be crossed out. So the mole fraction is a ratio, it's a number. It's one of the units in chemistry. Doesn't have any unit. It's one of the quantities, doesn't have any unit, is a mole fraction. So there is no any unit pertaining to mole fraction here. We just have a number. So basically 0.066 divided by 5.35, that would provide you about 0.012. So this is the final answer. This is going to be the mole fraction. So this is how mole fraction will be calculated. So the second question pertaining to this problem is we still have 4.95% of sodium hypochlorite, and we are looking for the molality. Remember, not the molarity, but the molality, small m. So molality is moles of a solute. Moles of a solute divided by kilogram of a solvent. Now, in many cases, we would have a problem to identify what is a solute, what's a solvent. A solute is a smaller amount. Okay, a solute is always in a solution with a smaller amount. That's going to be a solute. A solvent is the one that is in larger amounts. So that way you can identify what is your solute and what's your solvent. Mostly in water or in inorganic solution, water is a solvent, so you'll not be confused with water. But when we are dealing with organic compounds, it's very hard sometimes to identify if benzene or toluene is a solute or a solvent. Sometimes both of them are liquid, so you will have difficulties to identify which is your solute and which is your solvent. The easiest way that you can do is find out which one is a larger amount. Always the one that's in a dominating quantity is considered as a solvent. The one that has a lower amount is considered as a solute. So we have our 4.95% of sodium hypochlorite. So we know that we have 4.95 grams of sodium hypochlorite, and we have also 95.05 grams of water. So from here we're going to calculate the molality, which is moles of sodium hypochlorite, divided by kilogram of water, because that's your solvent here. Notice here that this is your solvent because this is in a higher quantity, and this one is your solute. Okay, so the moles of sodium hypochlorite can be calculated as by dividing 4.95 grams of sodium hypochlorite with the molar mass of sodium hypochlorite, which is going to be 74.5 grams. And that would give you 0.066 mole. Okay, now when it comes to kilogram of water, so we have 95.05 grams of water, and we wanted to change this into kilogram of water. So the easiest way to do that is by using a conversion factor, which is 1 kilogram equals to 1000 grams. So if we have 95.05 grams of water, to change into kilogram you simply divide 95.05 grams by 1000. That gives you, and times multiplied by 1 kilogram actually. So the unwanted unit will be crossed out here, and you would get 0.095 kilogram of water. So now you can be able to calculate the molality, which is the number of moles of a solute, 0.066 mole divided by 0.095 kilograms of water. So 0.066 mole divided by 0.095 mole, basically that gives you 0.695 mole M. Okay, or you can say 0.695 mole per kilogram of water in this case. Okay, so this should be your final answer. If you have any questions related with molality, you can ask on a comment, or you can put your comments on the video comment tab. So the next example I would like to do is molarity. So like I say, if you have questions related with molality or mole fraction, you can write a comment down below in the comment section. Okay, now we're going to discuss about molarity. It's a little bit different than molality. Molarity is moles of a solute, which is N, divided by volume of a solution in liter. Okay, that's the difference. Number of moles divided by volume of a solution. So let's do some example. Let's say that you have a solution contain 7.0 grams of let's say toluene. Okay, toluene. The chemical formula of toluene is C7H8. C7H8 dissolve in 245 grams of benzene. Okay, grams of benzene. So and has a density of the solution has a density of 0.876 gram per milliliter. So these are the given values. Now from these given values we are asked to calculate the molarity. So how do we get molarity here? So first of all, we need to find out what's our solute and what's our solvent. 7 grams of toluene mixed with 245 grams of benzene. By the way, the formula for benzene is C6H12. So I'm sorry, the formula for benzene is C6H6. What did I say? Okay, that was my mistake. I didn't say, I said C6H12, so C6H6. Now, solution. What's a solution? A solution is a solute plus a solvent. So we're going to add 7.0 grams of toluene, which is C7H8, plus 245 grams of benzene, which is C6H6. When we add this up, we get 245 plus 7. What do we get? So we get, I believe, 252. Yes, we get 252 grams of solution. Remember, this is a solution. Okay. So the reason why I need to calculate solution is the density of the solution was given, which is 0.876 gram per milliliter. Okay. So by using this value, we're going to calculate the volume. Remember, in the previous video, I said density was mass over volume, and from here mass equals to density times volume, and from here volume equals mass over density. So we have the mass and we have the density. We can calculate the volume. So volume would be what? Volume would be the mass of the solution, which is 252 grams, divided by the density, which is 0.876 gram per milliliter. Grams and grams will be eliminated. So 252 divided by 0.876, that would give us 287.7 milliliter. Okay, milliliter. So okay, now we have all the values that we need. Is we have the volume. The volume was 282.7 milliliter. We also have the mass of our solutes, which is the toluene, mass of solute, C7H8, that is 7.0 grams. And based on this information, we're going to calculate the molarity, which is a big M. Moles of a solute. Now, to get moles of solute, we have to divide 7.0 grams into the molar mass of toluene, which is 92 grams. For those of you, how do we get into 92? We multiply 12 by 7, because the subscript 7 tells you how many carbon atoms you have, plus 8 times 1. So 12 times 7 plus 8 times 1, so that basically gives you 92 grams. That's 1 mole of toluene. So now we divide 7 by 92. If you divide 7 by 92, we get about 0.076 mole. So molarity, again, is number of moles divided by volume of a solution, which is 0.076 mole, divided by the volume of a solution. Now remember, volume has to be in liter. So we will have 282.7 milliliter, If you want to change into liter, you have to divide this by 1000 milliliter times 1 liter. So that gives you 282.7 divided by 1000. You basically move the decimal place to 3 units to the left. So basically have 0.283 liter. So this value goes here. So the molarity would be 0.076 mole divided by 0.283 liter. So if we divide 0.076 mole divided by 0.283, that would give you 0.269 m, big M, referred as molarity, or sometimes in some literature you may see 0.269 mole per liter. So if you have any question related with molality, molarity, or mole fraction, please leave a comment in the comment section, and don't forget to like us, and I'll see you in another section next time. Thank you very much for listening.